This is not going to be a long video, troops, as I think you will be feeling about as done learning about electricity as I am making these videos. Automatic response circuits are things like street lights coming on automatically when it gets dark, or the central heating coming on automatically when it gets cold. The key bit of kit within the sensing part of these circuits is the special resistor, which for National 5 purposes come in two types. There is light-dependent resistors, or LDRs, and temperature-dependent resistors, or thermistors as they are more commonly called. With a light-dependent resistor, when the surrounding light levels get dark, the resistance of the LDR goes up. That's going to be quite important. Similarly, when the surrounding temperature gets cold, the resistance of a thermistor also goes up. By the way, the opposite is true too. When it gets light or hot, the resistance of both goes down. But stay with things getting dark and cold and the resistances going up for now. This circuit automatically turns on a bulb when it gets dark. When it's light, the bulb is not on. How the hell does this happen? The first thing to see is that there are two circuits involved. One is drawn in blue, the other is drawn in green. The second thing to see is that circuit number 1, in blue, is a simple series circuit. There is a light-dependent resistor, and then just a regular resistor in that series circuit. When it gets dark, we know that the resistance of the LDR is going to go up. Now if you remember the water pipe analogy, when the resistance of a component or blockage in the pipe goes up, the water pressure or voltage builds up. Circuit 2 is the green circuit. Circuit 2 is connected to the LDR part of Circuit 1 via a Gucci bit of kit called a transistor switch. A transistor switch is like a road block in the road that heads north from the lamp to the battery. When the LDR voltage increases, the transistor road block that is in the lead from the lamp to the battery comes down, allowing electricity to flow and the lamp to turn on. This is a circuit which turns on a heater in a reptile tank when the temperature gets cold. Circuit number 1, in blue, is a simple series circuit. There is a thermistor and then just a regular resistor in that series circuit. When it gets cold, we know that the resistance of the thermistor is going to go up. Now if you remember the water pipe analogy, when the resistance of a component or blockage in the pipe goes up, the water pressure or voltage builds up. Circuit 2 is the green circuit. Circuit 2 is connected to the transistor part of Circuit 1 via a Gucci bit of kit called a transistor switch. A transistor switch is like a road block in the road that heads north from the heater to the battery. When the thermistor voltage increases, the transistor road block that is in the lead from the heater to the battery falls, allowing electricity to flow and the heater to turn on. Finally, and this is about as complicated as it gets, this is the full fat, no punches pulled, circuit diagram of a street lamp. And as you may have noticed, there are 3, not 2, circuits involved, and a cool thing called a relay switch involved between Circuit 2 and Circuit 3. A relay switch lets one circuit turn on another without touching it. This isn't witchcraft, but the magnetic effects of electricity in a coil, pulling the magnetic switch shut in the red circuit. The street lamp you see needs a mains supply. It's a big old bulb and needs to be really bright. But if you connect the special resistors to the mains, they will go fizzle-whizzle melty-pop. This relay setup lets us have 2 separate voltage sources. It's like if I want a wee half pint of weak shandy, but my better half wants a full pint of Guinness. The relay is a way of letting that happen. I often tell people at bars about relay switches. They seem to want to leave, but I get to the bar quicker. If you've ever noticed a button-type thing on the top of a street light, it's not a button, it's the sensing part of the circuit with the special resistor in. Then the rest of the street light is all about the green and then the big red circuit to light up the bulb brightly with the mains. A mnemonic I use to remind me how to explain these circuits in an exam is that Roger vapes every day. When my Uncle Roger walks down the street, you think there is an enormous storm cloud approaching, but then you realize it's just him having a puff. You could substitute the name of somebody you know though. If you know anyone with a name beginning with R, when writing your answer, R stands for resistance. Talk about how the resistance of the special resistor is changing. In this example, the resistance of the LDR is increasing because night is dark. V, vapes, stands for voltage. So next you would say that the voltage across the LDR and transistor is increasing. E, everyday, stands for effect. The effect here is that the relay switch closes in the lamp circuit, which turns the street light on. Use the same explanation process. In other words, R, V, E, if the circuit has a thermistor and a heater in. rather than an LDR and a lamp.